So I want to touch on frost control, right? So it does depend on your climate. Coastal Washington, Seattle area, I doubt frost control is really too big of a concern. But if you are working outside of the city in different job sites, you do have to pay attention to frost control, right? So if we have a cold enough outdoor air temp, we may require it. It is also very dependent on the relative humidity of the space that we're exhausting from, right? So typical applications, we're going to be less than 35% RH in the winter. So anytime you're dealing with a job that has extra humidity coming from the space, I say the perfect example of this is like a locker room with some showers, right? That's a situation where we know there's going to be a lot of extra humidity uh, coming to the device in the winter. So you might want to consider frost control at that point. And then the last one on there that determines how often we need it is how effective the device is, right? So the more effective the device is, the less likely it is to freeze. What happens if we do nothing and don't think about frost control, right? So if it does start to frost up the device, we could lose that airflow. A lot of times these ERV or DOAS units are supplying that code required outside air, so you might not be getting that. And then also we're going to reduce that effectiveness and that energy savings, right? So it might not be performing optimally. So if we need it, definitely want to consider frost control. I just want to make a note here. So this chart kind of shows you the difference between an ERV and an HRV, right? So I know HRVs are pretty popular in your guys' climate as a sensible only device. One of the biggest things to watch out for with an HRV is you can see here that red line. Because it's a sensible only device, it's very susceptible to frost. And typically we see HRVs spec'd out on jobs with very large preheaters, right? So they use a lot of extra energy to prevent frosting up that HRV. Whereas you can see on that blue line, if you use a total enthalpy core, you're going to avoid frost significantly more. So as far as frost control goes, it's definitely a benefit to use an ERV over an HRV. And then just a handy map here. So like I said, most of coastal Washington, probably not a big deal. But as you move in, you might want to consider it. Some of the options that we offer at Greenheck, right? So you could have no frost control. It's relatively warm. Timed exhaust is one of the simplest strategies we have. Basically, the idea there is if we detected a frost condition, we're going to periodically shut down the supply fan. So stop bringing in that cold outdoor air and only run the exhaust fan, right? Very simple solution, not a lot of cost, not a lot of hardware. But obviously, the downside there is you're periodically shutting down that supply fan. If it's a bigger concern or a colder climate, then we would recommend going with an electric preheater, right? So the idea there being it's just too cold, we'll add a little bit of energy to that incoming outdoor air and keep the device running optimally and at full effectiveness. Right, so between wheels and cores, we offer both timed exhaust and electric preheat on both of them. Right. So one thing I'll point out with electric preheat is I think it's a common misconception that, this is the type of thing where it turns on in November and it runs through April or whatever it might be, right? We're only running the electric preheater when we absolutely need it, right? So when it is a frost condition. And then the last one that we have as an option, if you do go with an energy wheel unit, we also have an option for modulating wheel, right? So the idea here is we would slow down the wheel. That would allow that wheel more time to get exposed to that warm exhaust, and then that would act as our frost control. Really great option there. Not a lot of cost and really hardly any downsides to it. So if you're going with a wheel, definitely a great frost control option.